Okay, so thank you very much, Mr. Chairman. Can you hear me? Okay. Okay. So thank you very much for introducing me. I'm Tetsuo Sawaragi from Kyoto University, Japan, and I was former president of the SAIS. And first of all, I'd like to appreciate Professor Shinchai Komolov-Wong as the president of ECTI. Okay, just a moment. Okay. And also, I'd like to appreciate Professor Kosin Chamnon Sai. I think he's the former president of ACT Association. And I appreciate you for your very wonderful cooperation to our SAIS annual conference in the past, and for visiting us with their delegation last year. So today, it's a great pleasure of me, and it's a great honor of me to give you a talk as a keynote speaker. And first of all, I would like to congratulate on the successful opening of this conference. And I would like to appreciate all of the people, all of organizing committee people whose engagement in realizing this conference virtually. So thank you very much for inviting me. Okay, so I will give a talk on this topic. Okay, so I'm controlling the slides from Japan. And there is some time lags, so it is not so convenient. But please stand. Okay, this is my short CV, which appears on the homepage. So please look at this. Okay, so first of all, I would like to introduce an overview of our society. SAIS. This is the abbreviation of the Society of Instrument and Control Engineers. And it was established in 1961. And the next year, in 2021, we will have the 60 years anniversary from the establishment. And the chairperson and president is Dr. Akino Ono. He is from the National Institute of Advanced Industrial Science and Technology. And yes, he is a president from the past February. At that time, I redesigned and presidency. And I am now immediate past president of the SAIS. Okay. Yes, the SAIS has the members, this kind of numbers, and the society consists of the 6 technical divisions: measurement, control, system and information, system integration, industrial applications, and life engineering. And we have, at the same time, we have 8 local chapters, which are established on the district in Japan. We have the 8. Okay, so our SAIS realizes innovations that contribute to future industry and society by measurement, control, and system engineering as a hub for promoting open innovations. I think this is very similar to your ACTI policy, and we can share much with you. Okay? Next. All right. Okay, so this shows a very general view that our SAIS is targeting. Okay. And also, this is a general scheme showing the missions of control and system engineers to solve societal problems and create social values. The super smart society, or society 5.0, is being promoted as the 5th Science and Technology Basic Plan by the Japanese government in these 5 years. These three issues characterize this initiative. That is, number one, to realize smart manufacturing by utilizing IoT and network technology. And number two is to connect and fuse cyberspace and physical space. And number three is to systematize service and enterprise integration, enterprise integrating a variety of system elements. And the object to be controlled is a society which consists of a variety of activities: food, disaster, energy, environment, health, and especially we are now facing with the pandemic issues. So, do you know the IFAC? IFAC is the abbreviation of International Federation of Automatic Control. And I am one of the members of Team Japan. I'm sorry. We Japan will host this IFAC Congress 2023 at Yokohama, near to Tokyo. Yeah, and I am one of the members of Team Japan, and the team has made a bid for inviting IFAC World Congress to 2023. At that time, we set a Congress theme. Okay. At that time, we set a Congress theme as the Japanese word of wa, represent. Sorry. I'm sorry, the movie does not appear. Okay, sorry, I skipped the movie, but at the time we set the Congress theme as the Japanese word of wa, representing the harmony of traditional culture and innovative technologies. Okay? Yes, this wa. The word pronounced as wa in Japanese has multiple meanings. First, feedback as means of control. Data is the lifeblood of the user experience with systems that run. And what means ring or community as object of control. The object of science and technology is not a single individual, but a society. And what means harmony, the goal of the control. It would be significant to model and understand the dynamic complexity of the SOS, system of systems, and to develop a technique for guaranteeing their resilience. First, I mentioned about the feedback of this work. So cyber physical system has already attracted much attention to connect between the two worlds, physical world and cyber world. And the feedback to the things plays an important role therein. Be sure that the physical world is a place where, for activities of people. Thus, to establish the naturalistic feedback to the human, we should introduce a third world of cognitive world in the loop. This triad world architecture will contribute to connecting the living experiences, Lebenswelt in Germany, with the cyber world and the actual physical world. So we should discuss the design of experiences rather than the object, and based on these core concepts of system engineering. Okay. So we are now facing the pandemic issues and have discussed about appropriate countermeasures of national policies where the feedback of target system is essential. Okay. From the control theoretic view, this issue can be seen like this. The difficulty exists in the fact that the controlled object is a society, a community, consisting of interrelated people that have complicated dynamics. So instead of such a traditional control scheme, we would like to take this approach, DKP cycle. This is a data, knowledge, and performance. This scheme of the DKP cycle is very useful for realizing human and data-centric feedback. That is, this consists of K to P, knowledge to performance, and the second is P to D, performance to data, and the third is D to K, data to knowledge. So by iterating, repeating this cycle, we can establish a very valid this kind of feedback system to the society. And also, this cycle is very useful for taking care of the human healthcare. Okay? This is called the running health system. And we are now very interested in the quality of working life, QOW. Maybe you are familiar with the keyword of QOL, quality of life. But we are now interested in this QOW, especially for the elderly. As you know, the younger generation people population is now shrinking. And to overcome this kind of shrinking, we have to develop some means how to let the elderly people to continue to working with safe and with healthy. Okay? But in order to realize this, we need this kind of KPD cycle. Okay? Yeah. Let me explain this using our engaged topic. Yeah, this is a plurality. This is a clinical plurality scale. It was divided into 9 stages. Okay? These stages is classify the elderly people according to their heaviness of disease status. Okay? So this is very fit, okay, and this is quite serious. But the importance of this classification of plurality scale is the people can recover from the worst one to the better, okay? By having appropriate guidance. So we should carefully monitor how the worker are in which stage, and by giving them the appropriate guidance, we help them to recover from that stage to more better stages. And this frailty scale have been defined not only physiological dimension, but also psychological dimension and social dimension as well. So it's quite important how to monitor the elderly people working and how is their frailty is scale there now. And we should give them an appropriate guidance depending on their stages. Okay. And so concerning with this, we are engaged in this kind of sleep diagnostic advisor with a home sleep test. As you know, sleep disease is quite well known. And one of every 5 Japanese have a sleep disorder. The person does not notice this, and many have a complaint about the lack of sleep time, but they do not think it is a disorder. So 5 million sleep-inducing drug users and 3 million users over 5 years. So conventionally, this sleep disorder has been detected using this kind of quite complicated means. That is, this is a PSG, and the patient has to wear this kind of sensors in the head, and wearing this, he has to sleep, and during his sleep, some signals are detected and recorded, and the quality of his sleep was evaluated based on this data. So this is very important to judge the sleep disorder. So the sleep is divided into some stages, the REM stage and the stage 1, 2, 3, and 4. Okay? So how the distribution of these stages in some particular patient, and this is very important to judge in which level the patient has a sleep disorder. Okay? So for this purpose, we are using this kind of devices because the complicated wearable sensors are not appropriate for the patient because it prevents well sleeping. So we have used this kind of a sheet, but this sheet is a particular design and which has 800 channels on the seat. And this seat was put on the usual seat, and over there the patient is ashamed to sleep. So he or she has not wear any measurement devices during sleep. And this pressure distribution is measured, and this data will be recorded, okay, from the HAPIAC with the 800 channels. Okay. So individual point record this kind of time series data. Okay. And these data are again from the 800 channels. So this observed data is coming from the multiple sources. That is, the respiratory rate is included, and heart rate is also included in this data, and the body weight included, and other noise are included. So our mission is how to divide these observed signals into different sources. So for this purpose, we apply this MCA. This is a morphological component analysis, and we successfully separate this measured data into different source data. Okay? So by this, we can recognize in which sleep disorder the patient is. And especially what's important is some disease to find out whether he has such a disease or not. Okay. And at the same time, we also take another approach for this problem. This is evaluation of health guidance for the patient using a text mining method of LDS. LDA is a latent direct allocation method. This is one of the text mining methods. Okay? So the available data for this is the guidance report provided by the patient. For instance, this kind of sentences and how is the status of the patient and what kind of guidance he or she has made and how he was well recovered or not, etc. Such observed findings are mentioned in text. Okay? And these text data accumulate so many, and so we would like to extract to knowledge from these documented data. So at that time, we use text mining method of latent direct allocation, which deal with document and of course keywords and also a topic. Okay, the topic means that on which topic this document is just describing, and these are automatically derived. And so we can get the knowledge. What kind of guidance is appropriate for what kind of patient, okay, from the accumulated data. So this is how to extract knowledge from data by text mining method. So in this way, we can iterate the cycle of P, D, K cycle, and we can contribute to maintain the healthcare. Okay, and as another example of feedback, let me show our previous work on supervisory control of. Is it working? I'm sorry, this is a movie. Okay. Supervisory control of finishing mills in the steel factory. So this steel factory typically consists of 7 mill stands in tandem, and the looper control and the gauge control are embedded. But still, the supervision by a human operator is needed to handle the abnormal states. So this is an architecture of it's a human machine system, the human operator, and this milling process are partially automated by many automation technologies, but human still in the loop. And how to support is supervisory control is the target problem of this. Okay, in order to develop the human-machine interface, we have to do at first this as a systemic approach. The cognitive work analysis is well known. Okay? And this it can be divided into these 5 analysis methods. And this first work domain analysis and control task analysis majorly important. So this work domain analysis will be used to extract functional constraint within the system in terms of means and relations between functions. And control task analysis will be applied to see individual task structure to perform. Okay, so yeah, this is an example of abstraction hierarchy done by a work domain analysis for the finishing mill. In it, each node stands for a system function described from different point of view. The function can be viewed from the 5 different abstraction levels. From functional purpose, most abstract one, and to physical form, and as the most concrete one. The constraints are represented by connections between nodes in different levels. They stand for means and analysis, means and relations, stating that the lower level function must be realized to achieve the upper higher level function. The work domain model consists of such Y. The work domain model consists of such a why, what, how relation to describe the domain in constraints. This is a work domain analysis for the finishing mill. The topmost function are product quality and productivity. Then they are broken down towards the actual physical operation levels in the terminal nodes. Okay, and these nodes show the variables concerning the individual function making up the work domain, and the operators should monitor these during the supervision. So this is a conventional human-machine interface for this task. what is displayed here is close to the actual configuration and layout of the equipment in the target system, like this. At this time, the variables to be monitored by the operator are the same as the ones that are exhaustively derived in the work domain analysis, which is 243 variables, very huge. This means that this kind of interface make no contribution to reducing the operator's cognitive workload. And how to treat this complexity is due to the operator's abilities. So, another alternative of interface which are developed by us is like this one. This is our developed human-machine interface for the finishing mill, in which the displayed information is provided through this tunnel vision. Here, different sized square overlaid, each of which corresponds to the individual stand of the mill. The offset position of the square represents how the milling task is going well in terms of the physical variables of gauge, mass flow speed, the profile of the strip at each of the stands. When the task is going well, this is shown like this, so that we can see the ahead through the tunnel. But if some anomalous state emerges, the position of the rectangle begins to deviate from the symmetry. Thus, the tunnel vision itself begins to be skewed. Okay, for this original human-machine system, we are now developing some human-machine interface system, which is located here. How to display the information to the operator and how to promote him to react to the anomalies. Okay. So for this purpose, we introduce this kind of tunnel vision human-machine interface. And this is the actual display we designed as ecological interface design. Due to this, during the monitoring, an operator can immediately take notice of the anomalies and react to that. From the sequence of the deformation of the tunnel, he can estimate the following consequences unless he intervenes in the operation. Second dimension about another meaning of WA, community or link. Okay. Okay, connected factories of society 5.0 are illustrated like this, where multiple human-in-the-loop systems are connected with each other. Besides, the technology of IoT enables the management and the utilization of on-site data available in the factory plants. Besides, the development of wearable devices and the IoT will realize the novel idea of IOA, Internet of Abilities, where the abilities of different work people are connected, enabling distribution and sharing of their skills across time and space. However, separate from the simple sharing of production data, this kind of sharing of knowledge is quite a hard task. Okay, because of this straightforward nature of human knowledge. So this slide shows the expert basic knowledge, why it's difficult to obtain. Okay, so sometimes expert basic knowledge are called sticky information. Okay, so stressing its characteristic of extracting knowledge out of the vast accumulated data. That is, this is a difficulty in connecting the knowledge provider and knowledge user. So, of course, this part is the easy part. So this part of the knowledge can be transferred to the documents or manuals, etc. It's no problem. But what is difficult is for tacit knowledge or sticky knowledge. So it's quite difficult how to connect between knowledge provider and knowledge user. Okay? Because by processing the huge accumulated data, so this kind of phenomenon happens. That is, I want to extract some essence, but at that time, some other say debris coming together. Okay? So how to isolate this kind of textual knowledge will be a very important issue for us. Conventional skill transfer has been challenged in many ways. Making manuals or OJT on the job training and recording the performance in video, but none of these was successful. But now it is possible to gather workers' behavioral data, including motion and eye tracking, vital data, and also how the tools and workpieces are handled. So besides, qualitative data analysis of the interview excerpts is made possible semi-automatically by the natural language understanding by AI. So this is an example of the interviewed excerpt, sorry in Japanese, but interviewer and the interviewee. Interviewee is the expert, and the interviewer asks about his knowledge. So this exchange of the utterance ongoing during the interviews, but the individual utterance can be classified or tagged as question, confirm, identified, etc. And also propose, criticize, or questioned, and etc. So the current AI technologies enable us to automatically put the text for the individual utterances, and by tracing what kind of tag the utterance in sequence, we can detect what is the best dialogue structure, a conversational structure, which is effective to extract the knowledge from the experts. Okay? So the sequence of the tags should be learned by this kind of neural network, and what kind of interaction happens between an expert and the interviewer, and what kind of tags are exchanged in which sequence order. This is very important. And also, this figure shows that this is a result of the control task analysis, which I mentioned previously. And by taking the correspondence between these, is very effective to obtain the basic knowledge from the experts. Okay? So this kind of idea can be extended to this kind of cyber social coaching system. So this is a system used by the trainer and the trainee. This is a teacher and a student, okay? And the teacher shows some behaviors with some verbal cues, and the trainee has to understand his guidance and try to interpret it and behave by himself, and it is shown to the teacher, the trainer, okay? And then this trainer will put another guidance, and by iterating this cycle, the trainee can get the basic knowledge from the trainer. And also the trainer himself can get the knowledge how to teach the trainee. So I think this process is just a semiotic process. This is an interaction of the semiotic processes which are ongoing in the two actors. This semiotic process is originally proposed by Peirce, and it defined this triad relation among object, sign, and the interpreter. Okay? Sign is symbols or signs, and object is what this sign or symbol means. Okay? but this binary relation is determined by some particular actor, interpreter. So this triad relation is very important for this kind of teaching activity. So we think that this semiotic process are ongoing by the trainee and the trainer, okay? And the common signs are exchanged between them. But what is more important is how to interpret these signs in terms of their individual interpretant perspective. And by iterating this cycle, they get to know what this sign means. That is, they can reason about what their invisible object. So this is the essence of the interactive semiotic process and this co-coaching system. Okay, so let me skip this. And usually, this semiotic structure discussed for language. The bottommost is some sound of the utterance, and over there, some words, phenomena, and the word and the sentences built up. This is the original semiotic structure of the language. But not only language, but also in the human body emotions, we can define this kind of structure. And for the human behaviors, we can develop this kind of semiotic structure. That is, this dimension means a paradigm, and this dimension is a syntagm. The other characteristic of semiotic process is everything is organized along these two dimensions. One is paradigm. This is a class instance abstraction dimension, and this is a syntagm. This is let's say syntactic constraint. What sign followed what sign, etc. Okay. So in language issues, this is a semantic relation, and this is a syntactic relation. Okay. So similar to the language, the human bodily emotion can be also defined according to these two dimensions. So using these two dimensions, we can use these relations to the coaching system. So this is quite well known that this kind of motion data can be interpreted by the human quite easily. That is what they represent. As you know, this is a working of some man or two female. Okay? But why we can recognize this is working from just the very sparse data? So it's because that we are constructing some images in the brain and just from the past data. Okay? But at the time, the two dimensions, as I mentioned in the semiotic process, are very, very important. And having these two dimensions, we can recognize, oh, this is working. Okay? For instance, please compare this and this. I'm sorry, the movie doesn't work. I'm sorry, the movie doesn't work. But I would like to say that as dotted dots are shown, displayed in some random order, we can never recognize that represents the human working. Okay, so it's because that we can recognize the meaning of the motion based on two dimensions of syntagm and paradigm. Okay, and we are applying this kind of analysis and cyber coaching system to the Japanese traditional art of no play performance and also sports of lacrosse. Okay? How to teach lacrosse and how to teach such a Japanese no play. Actually, this is a scene of the no play was taught by some teachers to the students, and the student is assumed to perform and the teacher just say something, good or bad. Okay? So by demonstrating and showing her demonstration, the teacher has feedback some utterance, and based on this feedback, the student has to consider how to improve, which parts to improve, etc. Okay? And sometimes the teacher is demonstrating how to behave, and the student have to learn what the meaning of the individual motions. So for this, we have developed this kind of system, which captures the motions of the student and teacher but digitally, and by doing the analysis of the movement, and it is transferred to the student verbally, and how the student can improve his performance. Okay. Okay, so this is just an example. So finally, let me speak about what the harmony. Okay. So this is important to how to harmonize system of systems. The definition of a system of systems is shown like this. That is a super smart society will form an SOS, system of systems, where a variety of human in the loop systems coexist. The definition of SOS is like this, similar to the meaning of distributed autonomous systems, stressing components autonomy, but its features are agility, unpredictable holistic behaviors, and mutual influence, where emergency evolution was the two key words. Okay, so this is a picture showing the system of systems, and where the human in the loop system are connected with each other. Okay, so let me focus on this one elemental system. The human and the machine or automation should collaborate with each other, and their performance are linked to other parts. Okay, so actually, this kind of human-robot collaboration is becoming very possible. And but how to read the robot intention, or how the robot read the human worker's intention, is a very important issue to realize a very smooth collaboration between human and the robot. At that time, the perspectives, the human perspective and robot perspectives, and how to share these are very important issues. So here, I would like to stress this kind of substitution myth. This is always invalid. That is, in case where another replaces one system element with identical structure and function, it is necessary that the rest of the system has not changed over time. But this is a myth and not valid. I would like to say that when some new tools introduced, it do alter the tasks for which they were designed, indeed change the situations in which the tasks occur, and even the conditions for people and engagement. That is, if one element is replaced by another, it does not over, but it begin to affect the neighboring functions, and so the original one does not work as imagined. Okay? So this an autonomous driving system. This is a very hot topic now, but this can illustrate this phenomenon. Indeed, the technical safety issues have been carefully elaborated. But once this technology was placed in a particular driving context, what holistic behavior, including human interventions, will emerge is not correctly predicted. That is, not only technological issues, but also other human factors and organizational factors will affect. So the original procedure designed as work as done, the procedure originally as designed as work as imagined, is apt to change, to evolve into different actual work practice of work as done. So how to identify the gap between work as imagined and work as done, and how to respond to this gap is very important to guarantee the harmony between human and machine systems. And this is also true not only the driving situation, but also this kind of high-tech aircraft. Okay, this is a well-known incident happened 1 year ago, Boeing 737 MAX 8. Okay, so also so aircraft hardware and autopilot system are quite complete. And but in some particular situations, this work as imagined does not go well, and work as done was quite different from the what was imagined. Okay? So maybe this accident doesn't happen near your country, Thailand. That is actually it was in Thailand, and so you are familiar with this accident. So yes, this is from Jakarta to this, and when the aircraft start to take off, and after taking off, the pilot suffered from the unexpected response from the autopilot system. Okay, so let me skip the reasons why this happened. But actually, this is an example of the human technology coordination was not guaranteed. And some unexpected emergent behavior happens out of interactions of the automation and the human pilot. Okay? And I have to say that the quite similar and the same accident that happened in Africa, in Ethiopia, half year later. Okay? So also at this case, the cause of the accident was completely the same with the Indonesian case. Okay? So this is actual data, how the pilot tackle with the autopilot. But this is the Indonesian case and this is the Ethiopian case. It's quite similar. So anyway, so I would like to say that to investigate the safety of SOS, we should assume that the system behavior is always fluctuating and due to many factors of disturbances and variabilities. Of course, some countermeasures to overcome those are provided, but its validity is not always known in advance. What is important here is how to prevent the system from falling across the safe catastrophic boundary and visualize the dynamic transition of these. So in case of the two cases of aircraft accident, the pilot does not recognize this kind of boundary, and they are tackling with this kind of fluctuations, but they can never recover from such fluctuation. Okay? Okay, so for this purpose, let me introduce Eric Holnager's from scheme. Okay? I will explain this briefly using a single drug dispensing procedure. The pharmacist work task start when he gets the prescription from a customer. He does this. Sorry. He does these tasks in order. From present this as an interrelated function, each of which is defined by these 6 attributes, and by identifying the dependencies among functions through the shared attribution values. Fromm's goal is to predict the dynamic behaviors of the system of systems and to identify which connection is fragile or brittle under the possible variability. Okay? So first, we should define the procedure as a collection of these functions, and it was connected as a normal procedure. So this is work as imagined, and but we will give some variability or fluctuation, and then this procedure evolved and turned out to be another work as done. So through this analysis, we can identify which connection are brittle and which connection to be more should be more robust. Okay, so we have we newly developed a simulator for this problem that can output the evolution of behavior like this. Okay? The behavior of SOS is represented as the time sequence of the status of all functions. This is the 5 functions, so all functions, and the state of the function is described as how the function performs safely or not. That is determined based on the interaction of each function and the surrounding context. This is evaluated as quantitatively as PAF, probability of action failure. And this graph shows the transition of the safety status of the 5 functions. Upper values shows more dangerous catastrophic states, and the lower green values represent more stable and safer status. Okay? And this we are applying this simulation to the steel company's supply chain management system. That is a typical SOS system. Okay, the system is represented by the 7 functions as shown here, and run the simulation with the initial setting and variability, and assume that some countermeasure is taken at some particular time to overcome. Sorry, will not respond. I don't know why the system does not respond. Aziz, can you help me? The system does not respond, and I cannot proceed more.どうしよう。Okay, so is recovered? Yeah. Recovered? Not yet. Okay. Okay. The response of the system is quite abnormal, and I cannot explain the process well. But anyway, let me summarize. We apply such a supply chain of the steel company by expressing the Fromm model, and run the simulation. And yes, and this is the result of the simulation. And we can identify what countermeasure is valid when the supply chain was quite fluctuating. And we could identify it depends on the timing in which the countermeasure is taken, and in which status of the other functional states the same countermeasure is sometimes valid, but sometimes not valid. Okay, this kind of evolving scenario can be detected using this simulation, and we can identify the tacit knowledge that the engineer of the steel plant has known, has acquired, but it's quite difficult to explain why it is. So by taking this kind of simulations, we can realize this kind of tacit knowledge and visualize them as a process of this kind of simulations. Okay. Okay, so I want to show the last slide, but the system does not yet. Please go on. Okay. Yeah, this is the last slide. So in this talk, I summarize the issues to encounter in the coming super smart society, as well as the research activities conducted by the author and the colleagues from the three aspects of work. We are targeting social challenges such as global warming and the super aging society, but now we are facing two pandemic issues and how to design post-corona living society, because the working environment will drastically change and guaranteeing resilience is becoming more and more critical, and eliminate restrictions on work style is needed. So these three aspects of work were critical for design a new corona society, a new normal society with corona. Okay. Yeah. So thank you very much, and please show the last. Yes, thank you very much for your attention, and I'll see you again at the World Congress 2023 in Yokohama, Japan. Thank you. This, I will give you the control. Or some chairperson is there.
Yes. Thank you very much, Professor Tetsuo Sawaragi.
Yeah. Thank you.
So right now, actually, I have 5 questions from the audience.
Yeah.
So I will start with the first question. The first question is, could you give some examples of using cognitive work analysis in the workplace environment?
So I showed the example of steel companies, steel mill operations. So I'm sorry, I cannot go back to the slides. Yeah, in my talk, I showed some particular, yeah. I showed some particular this kind of system. Yeah, this is a finishing mill in steel production system, and work of this supervisor can be analyzed using the work domain analysis. This is like this, or like this. Okay, so his task is divided into different abstraction levels, and how the individual elementary tasks are related with each other, and what information should be referred to attain the individual functions. And our problem is how to display these huge number of the variables into a very compact way, so that we can avoid the human operators overload. Is this okay? This is the answer. And
yeah,
of course,
I think that should be good enough.
Yes, and of course, this work domain analysis can be applied any works. Okay, so it's quite a systemic way how to visualize the task. So yeah, it's a very good way.
Okay, thank you. So we move on to the second question.
Yep.
Does the cyber social co-coaching return the good results?
Yes. The cyber co-coaching system. Yeah. Yeah. Thank you very much. Yeah, actually, this application to this sport of lacrosse has over, and at the time, the verbal teaching to the trainee by the trainer was very good, and he could learn more sooner as compared with the learning by himself. But as for this Japanese traditional no play, this work is ongoing now, and we cannot show the result of the validity of the cyber social co-coaching. And for this purpose, we are now gathering the verbal data, which was exchanged between trainer and trainee, and we apply the text mining method and apply the artificial intelligence, natural language processing, and automated tagging was done. It is current status, and how to make the learning on the sequence of tags or sequence of advice will be the next problem we have to engage. And sorry, so the final results are not obtained yet, but it is such a status now. Okay?
All right. Thank you.
Yep.
So the next question.
Yeah.
Do you think that artificial intelligence can help with SOS system or system?
I see. So it's quite difficult to answer because in which area the AI covers. Okay. So as far as we are using such a from model from simulation, I think this is a part of AI, artificial intelligence, but it is deal with the qualitative reasoning and the qualitative definition of the functions and how to propagate the status to the other functions. This is quite similar to Bayesian networks ability propagation and etc. So I think such a modeling, holistic modeling method of AI is very, very attractive, and it should be applied to the SOS, the system of systems analysis. And we are dealing with this, and the scale of the SOS is not so huge, but the essence of the functional definition is we can abstract in different levels. So even though the actual SOS system is becoming quite huge, but the functional definition of this SOS can be described with just a few functions. This is a strong point of the functional definition. And so I think that the AI, especially such an AI's reasoning or functional reasoning system, is very valid and promising for analyzing the SOS, how the SOS will evolve, and how the countermeasure to the SOS can be validated. So the system verification and validation, I think AI is playing a very great role in the future. Is it okay?
Thank you. Yep, sounds good. For the next question, can your sleep analysis detect OSA, obstructive sleep apnea?
Okay. Yes, we are now collaborating with a medical doctor, and we are gathering such as sleep data. I'm sorry. Using this kind of devices. Okay, so the merit of this is it is not an invasive measuring method and non-invasive. That is, the patient asked to sleep just as usual. Okay, but during the sleep, such data during the sleep we obtain. So this can be done at home. This is a very strong point. Okay? So how to analyze this data is we are applying some method. This MCA is one of the methods, and it was quite going well to separate the source of the signals, such as the respiratory and heart rate and the body movement, etc. And the doctor can show us how to diagnose sleep disease. That is, how is the relation between the heart rate and the respiratory rate, and etc. And usually they have can show some annotation. They can describe in the text. Okay. And the problem is how to make link between the described annotation and with this measured data. Okay? So we are now trying to establish the linkage between the features extracted from this data and the annotation which was attached by the medical doctor, and how the feature is should be defined to make diagnosis for particular sleep disease. This is the current status of this research. Okay.
Yes. For the last question,
yeah,
the question is, by using motion analysis,
yeah,
how do you evaluate the effectiveness of degree improvement of learning results?
Okay. As a topic, we're applying semiosis process. Okay, the semiosis is not so popular idea, but very important because when we get the digitalized motion data, we can articulate these series data into some fragments. Okay. And how the fragment is connected in succession, or how the fragment in different part of the body is ongoing. Such a relation between those fragments are very, very important cues for understanding and for evaluating the skill of the motion of the performer or by the sport player. Okay? So the first step is how to segment into the fragment. And the second stage is how to make relations among these fragments. This is based on a semiotic process. And then we can identify what is the essence of the skilled performance out of those. So it can be very contributive to this cyber physical co-coaching system. And in addition to these data processing, we are now applying to acquire some verbal guidance knowledge from the interviews or from the utterance, and how to link between utterance and this measured bodily motion, so we can improve much more for the purpose of this co-coaching system. So this is the status of current status. Okay.
Okay. Yeah. I think that's all the questions that we have.
Mm-hmm.
Thank you again, Professor Dr. Tetsuo Sawaragi, for the very nice presentation.
Yep.
And answering all the questions.
Yeah. Okay. So thank you very much. Thank you for the audience. Thank you.